Howdy, I'm Garrett Barnett. I'm in Dr. Armin's Gen Chem 1 lab, and today we're going to be going over finding the density of unusually shaped objects. All right, so before you get started with your any of your lab procedures, first thing you're gonna need is your lab coat. You're gonna need proper safety glasses, closed-toe shoes, and of course your gloves for handling materials. So you've got your proper lab attire on. We'll go through some of the materials you'll need for this kind of project. So since we're measuring the density of unusually shaped objects, first you're going to need your unusually shaped object. Just a simple rock from some landscaping outside or hardscaping outside. This will be the object that we're measuring the density of. We're going to need something that you can pour liquid into, and you're going to need something that has some kind of measurement. So a lot of measuring cups do have a milliliter section or side of it, while the other side would be like in ounces. That's just so we can get a more accurate read. You can use, we'll have a scale as well. You can use a food scale if you wanted to go maybe a little bigger for the objects that you were measuring. I just happen to have one that does smaller measurements, and so I'll be using that. And then lastly, to record all of the data that you collect through your measurements, you'll need something to write on. So I have a whiteboard, but if you have a piece of paper, that works as well. All right, so first thing we're gonna do is we're gonna take our scale and we're gonna go ahead and power it on. The scale should already be set to 0, but just to play it safe, we're gonna go ahead and tear that, and so that's pretty much just zeroing the scale. Then you're gonna take your object and you're going to go ahead and place it on the scale. Once you get to your measurement, wait about 20 seconds so that you can get an accurate reading. Sometimes with certain objects, they fluctuate in your smaller figures down here, and so we're looking at 64.05 grams. We also wanna make sure that while you're doing your measuring, that your units are set to the right units. So this one does ounces and a couple of other different measurements, but we got to make sure that it's set to grams. All right, since measuring it, we're going to go ahead and record it. Just labeling it mass of whatever object that you're using and writing that down. Throughout our steps, any kind of measuring that we'll be doing, so next we'll be filling this cup up with some water to a certain milliliter count. You're also going to want to record that down, and I'll show you the before and after when that happens. As you see here, we took the measuring cup and went ahead and filled it up to 150 milliliters. And so with that, we're going to go ahead and record that on our piece of paper. All right, so now that we've got the mass of our rock and we've got the volume of the water that's put into our measuring cup, we're gonna go ahead and place the rock into the measuring cup with the water, and we're gonna see how much the volume increases. So if we can get that leveled out, maybe you can see with me. So it looks like we moved from 150 milliliters to 175 milliliters. So what we're gonna do is we're gonna record that, the combination of the rock in the H2O. And remember that we're gonna be keeping it in milliliters. Now that we have all of the calculations made and all the data written down, we're going back to trying to find the density of the unusually shaped object, in this case, the rock. So the formula for density is density equals mass over volume. And since we are trying to find the density of the object or the rock, we need to find these values according to that rock. So we already have the mass, and that would be 64.05 grams. And we're dividing it by the volume. So we have the volume of the rock in the water, and that'll be 175 milliliters. But we also have the volume of just the water by itself without a rock in it. So what we're gonna do is to find the volume of the rock, we're going to take the volume of the rock in the water and subtract it by the volume of the water just by itself. And so what you're gonna end up having is 175 minus 150 milliliters. And that's gonna give you 25 milliliters. Now it's a pretty simple just division problem. You're gonna end up dividing 64.05 grams divided by 25 milliliters. And that's gonna end up bringing you 2.562. All right, with an experiment like this, and just a good overall practice with many experiments that you do, is making sure that you run multiple trials on the experiment to ensure accuracy. So I went ahead and did those extra trials, and here are the data points that we got. As you can see, after running multiple trials, we have relatively consistent density values. So really the most you're gonna get out of my example trials are gonna be maybe about 0.3% difference. If you're taking on significant figures, maybe a little bit more. But most of this is probably going to be due towards human error whenever it comes to pouring. As you can see with my measuring cup, it is not an exact measuring cup. So yeah, there will be about 25 milliliters between each tick mark, which again, that's 25, or I guess that's 24 options in which you're wrong, right? And so it's not gonna be like the most accurate whenever it comes to this. And so again, this is just more like a ballpark experiments to kind of get you, like I said, in that ballpark picture of what the density of an object will be. If you wanted to carry out more experiments like this at home, highly would recommend purchasing more accurate measuring apparatuses. All right, and that should be it for this lab activity. It's a pretty simple lab activity, very light on calculations, and it's pretty easy for most people to do within their household. Just to be sure, whenever you're done with lab activities, you should clean off all spaces and wash your hands afterwards. Typically, if you're dealing with more harsher chemicals, that would be more important. But even with things like rocks that you find outside, you don't know what kind of germs could be on them, what kind of animals could be digging around in them. So even after you take off your gloves, sanitize your hands, sanitize surfaces, and you'll be all good. So thank you guys for watching. And to whoever is watching this video, I hope that you guys have a wonderful Christmas break, and that hopefully I'll see y'all again next semester.